Let's continue our math adventure. We've been learning about ratios and proportions, but we haven't really seen how we're going to use them. So that's what we're going to start to do today. And what we're going to look at is we're going to look at similar and congruent figures. Now, similar figures are figures that look to be the same shape, but not necessarily the same size. By definition, mathematically, a similar figure will have corresponding angles. Now, the word corresponding means in the same position. So corresponding angles that are equal, but they're going to have corresponding side lengths that are proportional. And that's where we're going to bring proportions in. So let's go back and take a look at these two figures. They're both triangles. When we're looking at corresponding angles, remember, those are the angles that are in the same position. So A corresponds with D, B corresponds with E, C corresponds with F. Now, by definition, those angles have to be the same measure. So angle A's measure is 53 degrees, angle D's measure is 53 degrees. I'm thinking we have a similar figure. Angle B is 35, angle E is 35, angle C is 90, angle F is 90. Right there, I see all their corresponding angles are the same. Now we're going to take a look at the side lengths, because remember, in similar figures, the side lengths have to be proportional. So when I take a look at the corresponding side length, I know AC corresponds with DF, and the measure of that side length is 6 and 9. Well, in order to see if these are going to be proportional, I have to set up proportions. So I'm going to set up a ratio, and I'm just going to do small to big. So I'm going to keep that small number always on top of the ratio and the big number always on bottom. So I'm going to set up a ratio of 6 to 9, but I have to do it to all the side lengths. So I'm also going to have 10 to 15 and 8 to 12. So I always took those side lengths that were in the same position. Now I still don't know if they're proportional. So this is where I have to reduce it to lowest terms. So I take each of those ratios. I don't divide by the same number for each one of them, but I'm taking it down to lowest terms. So 6 to 9, I can divide both the top and bottom by 3. I get 2 to 3. For 10 to 15, I divide by 5, and I get 2 to 3. And for 8 to 12, I divide by 4, I get 2 to 3. If they are the same ratio in lowest terms, then they have to be proportional. So this is by definition a similar figure. Now, congruent figures, everything about them is the same. So their corresponding angles are identical. Their corresponding side lengths are identical. They literally are the same shape and the same size. You could put one on top of the other and they would fit perfectly. So these would be two congruent figures. Now, these are easy to work with because mathematically they're absolutely identical. Now, what you're probably going to be finding yourself doing is you're going to have to be showing a lot of corresponding angles and corresponding sides. And so the way that we show that mathematically is a new symbol that you probably haven't seen before. We use one squiggly line, and that means is similar. So we're coming back to the concept is similar to. So if I were looking at corresponding angles, remember, always in the same position. If I needed to write that mathematically, I would use the symbol for angle, which is just that little kind of like triangle without the one side on it. So this says angle A is similar to angle D. Now I know that means that they have to be identical. And angle B, because it's in the same position as angle E, has to be similar. So angle B is similar to angle E. And I know C and F are in the same position and they have to be the same angle. So angle C is similar to angle F. Now we can also use that symbol whenever we're looking at corresponding side lengths. Now remember, we're talking similar. They're not the same, but they're proportional. And as long as they're proportional, then we can use that similar symbol. So again, I need to write it correctly mathematically. So I'm going to put the segment line above the AB, and I always write these letters in alphabetical order. So A would always come before B. I would never write BA. So this is segment AB is similar to segment DF, but remember they have to be in the same position. So AB is in the exact same position as DE, therefore they have to be similar. AC is in the same position as DF, therefore they have to be similar, and segment BC is in the same position as EF, therefore they have to be similar. Now you can only write that they're similar if you've seen that they are the same as a proportion in lowest terms. So you can't do that with anything, because if it doesn't work out to be the same, you can't do this. So that is your journey for today. You're looking at similar and congruent figures. Good luck.